What's up guys, in this video we're going to be talking about geometry proofs, or the proofs that you might do in geometry. So what are proofs? Well, proofs are basically you want to prove a statement. You give a list of steps to prove something. For example, let's talk about a basic algebra equation. Let's say you know that x plus 1 is equal to 2 and you want to prove that x is equal to 1. You cannot conclude x is equal to 1 without doing anything, right? There has to be an operation involved. Well, obviously if you've done algebra enough, you would know that you would have to subtract 1 from each side, which is pretty simple, and you'll get x is equal to 1, right? And then x is equal to 1, while x is plus 1 equals 2. But in geometry, a proof would be more formal, but it wouldn't include all the algebra needed. For example, in a proof, we would have steps involved to get to what we want to prove. Right? We would have different reasons to show our work, and we would need the right amount of steps with precise detail to prove x is equal to 1. Right? So, what should we do here? What do we start with for a formal geometry proof? Well, let's start with the two-column proof. What is a two-column proof? A two-column proof is basically a proof with two columns where you have statements on the first column and reasons on the second column. You start with the given statements and work your way up to what you need to prove. And you must also give a reason for each statement. So let's start with the first statement. Our first statement is going to be x plus 1 is equal to 2, which is given. Our next statement is, well, x is equal to 1. And that's because of the subtraction property of equality. Yeah, long words. But that basically means that if you subtract the same number from each side, the equality will remain the same. Meaning x will be equal to 1 and x plus 1 will still equal to 2. This also works with multiplication property of equality, division property of equality, and addition property of equality. Obviously, with multiplication and division, there's a 0 involved, but geometry, we don't really deal with zeros because, well, there's lengths and measures that are 0. But anyways, you get the point. That would be our two-column proof. We just proved that x is equal to 1. But no, this is only like an example, right? In geometry, we would be getting into larger proofs, and we need more reasons and more statements to prove something. Even one of the easiest proofs will have 3 to 4 steps. So let's get into the geometry. So for a very short geometry example, we can have a pair of intersecting lines where they form vertical angles. And we would have another angle just sitting there to the side, which is going to be equal to one of the vertical angles. And what we want to prove is that this angle would be congruent to the other angle. So let's get started. So we can put up a t-chart, which is where we put our two-column proof, and let's come up with the first statement. So what do we know about this? What do we know about this diagram? What are we given? So the first thing that we are given is that angle 1 is congruent to angle 2. So we can write that down. Okay? And that's all we're given, and we want to prove that angle 1 is congruent to angle 3. What's our next step? Well, we can say that angle 2 is congruent to angle 3 by vertical angles theorem. What are vertical angles? Well, when you have a pair of intersecting lines, the angles opposite of each other in those intersecting lines are called vertical angles. That means those angles will be congruent. So, anyways, we have angle 2 is congruent to angle 3. Now, since we know that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then by the transitive property, angle 1 is congruent to angle 3. And there we have it. We just proved a statement. Now, I'm not going to go into any more examples, but basically in proofs, you have to logically, step by step, figure out what you're trying to do. Now, there are some occasions where you can prove it many other ways. And some of the ways that you may get into triangles, you may be more using, SAS and ASA and all those postulates, even HL, all of those. But when you get maybe into circles or parallelograms, you would have different type of theorems that you would use in that category. This was just, a pair of intersecting lines. But you may be asked to prove triangles are congruent if a measure of an angle is equal to a certain number of degrees. There are multiple proofs, and all you gotta do is take it step by step. And it's like you're trying to prove something to a person who doesn't really know anything about geometry, and you gotta explain it like that. Thank you for watching this video. I hope you learned what the two-column proof is and how to prove statements. Yes, this was a easy tutorial, but I just wanted to go over the basics of geometry proofs. Thank you for watching.